Hello everybody, the machine I would like to introduce today is this Shakeout. This Shakeout is typically arranged in a green sand foundry after the punch out of the mold line. In this case we have a HWS mold line, a EFA5 with a mold dimensions of 1000 by 920 by 650 and the performance is 80 molds per hour. It is a chopping foundry and they have casting weights up to 300 kilograms, ductile iron and gray iron. What are the most important features of this Shakeout? Because this Shakeout has undergone multiple developments and improvements in the last couple of years. First of all, if you have a look at the machine body, you can see that this machine body, the sidewall, the most stressed part of the machine body, is completely free of any welding seams. So there are no welding seams applied to the sidewall to avoid any partial thermal treatment of this material of the sidewall. This reduces stress peaks, avoids stress peaks. Everything which is applied to the sidewall is riveted or bolted and it is exchangeable. We have, in the last couple of years, we made very good experience with this design and machine body failures dropped down to zero. The next important feature is the design of the screen deck. The screen deck, you can see a small sample here. The screen deck is manufactured of manganese steel, plate thickness 30 millimeter. It features trapezoidal shaped apertures which are declined against conveying direction. So the goods on the screen deck move in this direction. And this design avoids materials getting trapped inside the aperture. If something drops down here, it won't drop through the hole and the machine has enough dynamic energy to throw out this piece which dropped down here again to avoid clogging or blocking of the conveying motion on the screen deck. We have cut this one here and you can see the design. There is a zero overlap between this edge and this edge. Also very important, this aperture is tapered. Here we have 30 millimeters, at the lower end we have 32 millimeters. This is also very important to avoid clogging and plugging of the apertures. Thickness is always 30 millimeter. The pitch, the length of each screen deck section is 400 millimeters. They are always bolted and exchangeable, made of wear resistant manganese material. This is number 2. Regarding the drive units, we have exciter cells. The exciter cells are bolted to the machine body and this connection from the exciter cell to the machine body allows very good heat transmission from the bearings to the sidewall of the machine, which acts as a heat dissipation fin. The next feature of this unit is we have a special seal here. It is a kind of labyrinth seal, an axial labyrinth seal, which protects the elastomer seals, V-rings, from the sand and from the dust. And another important feature, these exciter cells are balanced. This means the flyweight we can see here, there's a second flyweight on the inside of the machine. It's not visible here, but it sounds strange. The unbalanced exciter cell is balanced. This means there is no dynamic bending moment transmitted in the sidewall because the dynamic force here and the dynamic force on the inside, it's exactly the same. So we avoid bending moments in the sidewall with this method. So stress is not introduced in the sidewall, and if you don't introduce the stress, you don't have problems with it. Number four, sorry. We have electronically adjustable vibrating angle. Now this machine can be controlled from a vibrating angle from 50 degrees. We call this a flat vibrating angle up to 85 degrees. Theoretically, it is possible to increase this range, but from the technological point of view, it makes no sense. The vibrating vector of this machine looks like that, and it is possible to separate this vibrating vector in a vertical portion and a horizontal portion. So this is the stroke of the machine. Stroke is fixed. Here we have 4.3 millimeters at the vibrating frequency of 25 Hertz. And here we have the sinus portion, and here we have the cosinus portion of the stroke. This one is the destructive portion, and this one is the conveying portion. That's quite important, because the destructive portion and the conveying portion changes massively if we change the vibrating angle of the machine. If we compare this, here we have 50 degrees of vibrating angle, and here we have 85 degrees. An object on the surface of the machine will move like that, with 50 degrees. So the angle here is 50 degrees. It looks completely different if we investigate the object moving under a vibrating angle of 85 degrees. This will look like that. Now you have three effects. Effect number one is, here you have much more impacts compared to this one. Effect number two, the impacts here are much harder compared to this one, because the sinus portion from here to here it is much larger. This is effect number two. Effect number three, the traveling time. On the shakeout surface, the treatment time of the materials which travel on the shakeout surface, it is much longer here, because it takes much longer for the materials to go from here to here, because the cosinus portion of the conveying vector is much smaller here. This means the treatment time here is longer compared to this one. So, and the important thing is that those three effects, the treatment time, the hardness of the impacts, the vertical impacts, and the number of impacts, all those things move in the same direction. They interact with each other, there's a synergy. And that's the reason why changing the vibrating angle on a shakeout machine is a very, very effective method to adjust your vibrating parameters in your foundry to your requirements.